Good morning, everyone. Thank you very much for coming to my talk. My name is Edison, come from ARM, and I'm sorry if the other authors cannot join this session. So my topic is skill partition runtime library on IoT device. This is the main content. Firstly, I will describe the main basic information about platform security architecture, firmware framework, and the second is about what's in skill partition runtime library. And third is the placement of skill partition runtime libraries, and then I will describe the design of skill partition runtime libraries, and the last is about the project status. So, the platform security architecture firmware framework, short name is PSA is software part of platform securities architectures. I will not describe the PSA in this talks. I only focused on the domains of PSA. So this picture is the overviews of framework architecture defined by PSA. So we can see the execution of system is divided into two domains: non-skill processing environment and the skill processing environment. The non-skill processing environment, whose short name is NSPs, mainly consists of applications, libraries, or OS kernel. The skill processing environment, whose short name is SPEs, mainly consists of skill partition and the skill partition manager. So what is skill partition? The skill partition is the unit of solutions. It is an execution environment for root service. It will provide belongs functions to root service and provides access to its resource, protects its data and code. And it also provides the mechanism to interact with other components in the system. The skill partition manager, of course, is mainly used to manage the skill partitions. It will provide the isolation logic, shortening logic, and the inter-process communications for skill partition. The main characters of security is solutions. So PSA also proposed 3 different isolation levels to access its data, to protect its data, sorry. So this is the solution level 1. The SPE is protected from access by the application firmwares and hardwares of the SPE. The solution level 2, in addition to solution level 1, the PSA's root of trust is protected by access from the application root of trust. As solution level 3 is in addition to level 2, each skill partition is protected from access by other skill partitions. So this is the basic information about the PSA. So when skill partition is processing, it needs more interface rather than its own interface. And we can divide those interfaces into 4 parts. The first part is C runtime. It will include printf, aside, and the heap operator interface, and memory operations interface. The second part is the PSA APIs. The client's API and the skill partition APIs are mainly used to communicate with SPM for applying service and handling inputs. The root service APIs are mainly used by application clients to applying service from root service. And for example, the APIs from the skill storage, crypto. And the third part is skill partition launchers. It is mainly used to initial necessary dates for skill partition before entering its main entry. And the last part is Miscellaneous APIs include the boot date API and some special SPM APIs. Oh, you may think that there are no more APIs and no special within them. Yes, of course they are like common APIs, but all of these APIs must be implemented with security considerations. And what is the request in PSA for this? First, the only code is executables. And secondly, is the only private date is readables, and the last one is and the important one is the private date must be excluded. So I will describe what we can do to light the skill partition to allow with those requirements. About how to placement the skill partition runtime library, the first option is per-partition libraries. This is the direct ways we think out. In this method, the skill partition will be put in. In this method, the skill partition runtime library will be put into each skill partition, and they will be associated with skill partitions. So we don't need to worry about the security issues in this method, and it will meet the solution requirement we just mentioned. Yeah. But there are some shortages in this method. The first one is it will increase the image size much more. This is sensitive to IoT device because IoT devices are resource limitation. The second is it is hard to put the runtime libraries into a single loaded image. We must to think more about how to distinguish the skill partition runtime library between different skill partitions. So to improve this method, we think out another solution, or by supervisor calls. In this method, the skill partition runtime library will be put into skill partition managers. And because the skill partition works in the thread mode and the skill partition managers works in the handler mode, so all the function calls to the skill partition runtime library will involve the supervisor call to SPM. So in this method, the advantage is only one short runtime library is enough, and which will reduce the memories. But it also has some shortage too. The first ones, the SPM will need more execution times, which will increase the load of the system. And second, the runtime libraries executions cannot be preempted. And thirdly is the runtime library code runs on the necessary privilege mode. So we think out other solutions for the partition short libraries. In this method, the skill partition runtime library is put in thread mode, and it is short by all skill partitions. In this method, the skill partition library is code only, and no readable global in it, and all the private dates should be belong to the skill partitions. So it also meets the solution requirements we just mentioned. So the main characters about this method is this. The first, it is fast and efficient. Only some interface, only some function need to call the service from SPM will involve supervisor call. Secondly, Same with method 2, it will reduce the memories, but one dedicated MCU regions need to reserve for this library. Okay, so these are well-balanced implementations, and this is what we choose. So nextly, I will mainly describe the detailed design about the skill partition runtime library. So the first is about how to launch partitions with the runtime libraries. We can see in these pictures, the skill partition runtime library is the wrap layers for the skill partition. In the system initial stage, the skill partition manager will jump to the main entry function of skill partition. Runtime libraries is SPRT main function. And then the runtime library will get the runtime metadata from the skill partition. The metadata will mainly include the information about the skill partition and the its heap. And then the skill partition runtime library will initiate the SP heap information and put the heap manager instance into the runtime metadata. And next steps, the skill partition runtime library will jump to the main interface of skill partitions, which will load the real thread. After that, the SPM needs to catch the program errors if the main thread exists. Okay, for this method, you may ask why not like the SPM to launch the skill partition directly. So we have two reasons. The first one is the skill partition developers may need to access a heap information, heap memories directly after entering its main interest. So it is not suitable to let the skill partition developer to init the heaps by itself. And the second reason is it has some potential security issues if let the SPM to initiate. So it's why we choose the let the skill partition runtime library to do it. The second one is the function call to skill partition runtime library. And in here, the function calls means the function to the skill partition runtime library will not involve the supervisor call. And it will call back to the callers directly after it finishes. So the process is like this. First, the skill partition will call the function from skill partition runtime library, and the runtime library maybe get runtime metadata from skill partition, and maybe it will need to access the memory information of the skill partition. And after it processed all the requirements, it will function back to the skill partition. In this method, there is implied passing parameter we need to think about. For example, for the malloc functions, we need implied parameter to pass the heap instance from the malloc to its real implement function. Yeah, you can refer the design document for detail about it. The other scenarios is about the supervisor call of the skill partition runtime libraries. The process is like this. First, the skill partition calls function of skill partition runtime library, and then the skill partition library will involve the supervisor call to SPM And the SPM will process the requirement, and it may access the memory information of the secure partition. After it finishes the process, it will supervisor back to secure partition runtime library and then function back to secure partition. And in this method, it will include those interfaces such as PSA client APIs, secure partition APIs, miscellaneous APIs, and print function. So last one is about the project status. The designs about the secure partition runtime library had to be published to transformer.org. And about the interface status, the PSA FF APIs, we almost finished the 16%. For C runtimes APIs, we almost finished about 13%. The secure partition launchers, we just finished about 10%. And for the miscellaneous APIs, we had finished about 13%. And you can download and refer source code about TFM from this link. This is almost all the contents for my topic. Any question?
I'm trying to understand this a bit more better. So in one of the options initially you mentioned the runtime library could be part of the secure partition manager, and the risk over there you highlighted, okay, you are basically running something in an unwantedly higher privilege. So in terms of the shared option, you had one option where you mentioned, okay, probably the heap and the code actually goes within the secure partition, where I believe my runtime library is now running at the privilege constrained by that individual secure partition. But on the other cases, at what privilege would that be running, if the question makes sense?
You made the difference with this option 2.
Yeah, so here you mentioned, okay, it's a risk from a security perspective because we are running the runtime library in the secure partition, which is all higher privilege. Yeah. Then if you go to the next slide, I think you have the other options where, say, that's where the shared option, and there I think we had those 3 individual options where one is function calls, another one is you would actually prepare it within the secure partition. So in those contexts, what is the privilege where we are running? Am I still running on an unwanted higher privilege or not?
Okay, so for these options, we can say it's we put the secure partition runtime library on the SPM, and the SPM works in the privilege mode, but the secure partition works on the thread mode. So if the secure partition want to call the functions from the secure partition runtime libraries, all the function call will involve the supervisor call to SPM. Yeah. So it will, so that's the first reason, at least the SPM need more execution time. Yeah. So because SPM works in the I think the high privilege mode, and it will cannot be interrupted by other service or hardware interrupt. Yeah. So it will need to spend more time in this mode. Yeah. And for the second reason, the secure partition runtime library executions cannot be pre-embedded. Yeah. So in the option 3, this is what we choose. In this method, the secure partition runtime library will be put in thread mode. So only for the function which we need call service from the SPM, they need involve supervisor call. But for the other function, for example, the memory functions and the heap functions, we can process all the requirements in the libraries. We don't need to involve supervisor call to SPM.
Just to clarify my question, I think.
Sorry, please use the microphone. Yeah.
So in the isolation level 3, you mentioned I do have a partitioning between the PSA root of, or the SP element where PSA root of trust service is running from the other secure partition. So in this shared mode, does that mean my secure partition runtime library, the shared one, is actually running at least in the same privilege as the PSA root of trust service SP element?
Yeah.
Okay.
Yeah.
So
No. So in this context, whenever you make a library call to the runtime library, since it is a simple function call, so you would always get the privilege level of the caller secure partition. If that is an unprivileged partition, then the runtime library would be executing unprivileged. If it is a PSA root of trust partition which is executing in privileged mode, then it would be, of course, executing in privileged mode. But it would, since it's a function call, it would just use whatever privilege level it is already executing in the
so
secure
it
partition.
always inherits the caller's privilege, and in that context, and once that context is switched, then obviously it goes to whoever is the next caller and its privilege.
Exactly. Yeah.
Yeah, because it's the only, it is code only and no global writable dates in it. So there will not data share between secure partition. Yeah.
Because I was thinking, what if that shared runtime library is an exploit, and if at all that turns out to be compromised, and to what extent it could cause harm? I mean, that was my kind of reasoning in terms of asking what privilege I would be running there.
So if that runtime library is compromised, this is an embedded system, and this is so the partition runtime library code is delivered, is bundled together with the TFM core code. So it's delivered in a single bundle. It's signed together. So if that is compromised, then basically all the secure privileged code is compromised as well. So
okay,
that needs
there
to
is
be
a first level of defense there.
Yes. So that is definitely a highly sensitive piece of code.
Okay. Thank you.
So no other questions? Yeah. If you're interested for this and you have more questions, you can connect with us, or you can send email to Just Firmware. Yeah. So thank you very much.